Hi guys, welcome to week 6, and this week we'll be covering the rest of chapter 31 and finishing up with the chapter 31 test by the end of the week. So other things that are due in addition to that chapter 31 test by Sunday night at midnight include the forum as well as the week 6 assignment. So our reading goes from page 886 to page 894. Sometimes it's a little hard to talk about math in a lecture, so I encourage you, if you have any questions, reach out to me individually or find someone on campus who can help you. Maybe it's someone who took the class before or somebody in the library. You might want to look into tutoring because this is an important piece of the puzzle to get. So we'll jump right in here. So rounding equations, we always round to the nearest tenth when giving more than 1 ml. So if you had 1.05, you'd round to 1.1. And we round to the nearest hundredth when giving less than 1 ml. Okay, so when we have 1 through 4, we round back down, and we round up from 5 to 9 to the next 0. It says see table 31.7, so let's head over that way. 31.5, 31.7, and that just gives you the same rules that we're working on for liquids. For solids, when the tablets are not scored, round to the nearest whole number of what's available. So if you've got 1.7 tablets, we're just going to give 2. And if the tablets are scored, you can round to the nearest whole or half tablet. And again, 31-7, that table discusses that rule. So there's a couple different ways to calculate to get drug dosages. One way is the proportional method. And in this method, you're going to determine if the dose ordered is in the same units as the dose on hand. If not, you want to turn everything into the same units. So maybe what you've got on hand is in milligrams, and what you have an order for is in grams. So you're going to want to convert what you've got ordered from grams to milligrams so you can figure out exactly how much you need. Step 2, we're going to set up a proportion to calculate the dosage, and just like in algebra, this is just solving for x. It should be a super straightforward fraction on one side equals a fraction on the other side, and there's an x somewhere, and we're going to solve for that x. And step 3, of course, is remember that a proportion is the same as a fraction, which is kind of what we just said. We're going to cross-multiply the numbers, so if you've got x on the bottom, you're going to cross-multiply it with the number on the top, put that on one side of your equation, cross-multiply the other side, put that on the other side of your equal sign, and then we're going to solve for x. So let's say you have 5x equals 25. You're going to divide out 5 on each side to get x alone, and then you'll have x equals 5. 25 divided by 5 is 5. And to check whether the answer is correct, just insert your answer into the original formula in place of x and cross-multiply. The next one is the formula method, and this one is, I gotta be honest, isn't one of my favorite. You set up the amount desired over the amount available times the quantity, how it comes stocked. For example, 1 ml, 1 capsule, 1 tablet, 5 mLs. I tend to prefer the proportion method just because that's how we learned in algebra, and you don't even have to get confused with the units. It's basically just solving for x in fractions. Okay, so calculating pediatric dosages. This is where we want to be super careful, get stuff double-checked, and always make sure that the dose makes sense for our little ones. So we can use body surface area, which is basically a calculation of how much area there is for the child's body. This can be used for infants and children up to 12 years of age. And we generally use a nomogram that is a graph that illustrates the relationship between two known values, so in this case, height and weight. Where the numbers intersect is the body surface area for that child. And if we place the body surface area of a child in meters squared over 1.7 meters squared, multiply it by the adult dose, that will give you the child's dose. You can see an example of the nomogram in figure 31.1. We don't use these too often. Usually a BSA is supplied to us by the ordering physician. We can also calculate pediatric dosage by kilograms of body weight. So if you convert pounds into kilograms by dividing pounds by 2.2, round the answer to the nearest hundredth, and multiply the dose ordered by the kilograms of body weight. So for example, if you've got 5 milligrams per kilogram and you have a 20 kilogram child, your dose would be 20 times 5 equals 100 milligrams. If applicable, you may need to divide the child's dose by the number of equal doses to be given in a 24-hour period. And this would look something like 10 milligrams per kilogram per day divided into 2 doses. So again, if we have that 20 kilogram child, we multiply 20 by 10, that gives us 200. And if we have to divide that into 2 doses for the entire day, we know that each dose is going to be 100. So 100 in the morning, 100 at night, we'll get our 200. Insulin dosages. We want to be always very careful with insulin. If you guys remember, it's a high alert medication. Insulin is measured in units instead of milligrams or grams, and it's administered with a special U100 syringe. We don't want to use a standard ml or cc syringe because they're not calibrated to measure insulin. And if you remember, errors in dosages can lead to serious complications, hypoglycemia, coma, or even death. So when mixing insulin, we also want to make sure the two are compatible. We don't mix a ton of insulin in our ER just because we usually only give rapid acting. We're very rarely long acting. So, types of insulin. Well, let's finish up with mixing insulin. If you have to mix insulin, you want to straw up your clear insulin first and then your cloudy insulin. And the types of human insulin include regular, which is a short acting. That starts working 30 to 60 minutes after administration and lasts for 3 to 6 hours. This is usually called insulin R, Humulin R, etc. Intermediate acting starts working 2 to 4 hours after administration and lasts for a lot longer at 10 to 16 hours. And premixed would be a mixture of both, so Humulin 70-30, Humalog 75-25. Usually those numbers are letting you know how much of each insulin there is in each unit. So, analog insulin medications. Analog insulins are insulin medicines that have been altered to help in faster absorption or last longer in the body. And those include rapid-acting insulin, and that means the action is very quick, 15 to 60 minutes after administration, and it's usually taken right after a meal. And long-acting insulins are usually the longest acting. Usually they take about 4 to 24 hours to work, and they can control your insulin. This is called a basal control for the entire day. And again, premixed. This insulin provides both intermediate and fast-acting effects, and they give you a couple of examples in the book as well. So reading a label. If any of you are parents, you've probably read a few labels in your life giving your kids medications. So just to go over each of the parts of the label, right? We've got that tamper-resistant seal up top. All bottles should hopefully come with that, some way to determine that it hasn't been tampered with. The product name, statement of identity, in this case antacid liquid, a listing of all the active ingredients as well as the inactive ingredients, which are usually just fillers or dissolvers. Your active ingredients are your drugs that we are looking for to do the correct indication or job. How much quantity there is, so in this case 12 fluid ounces, and the name, address, or manufacturer, packer, or distributor. On the rest of the bottle or box you might see indications for use, as well as special directions and dosage instructions. There's also going to be warning and cautionary statements, as well as drug interaction precautions. And at the bottom you see an expiration date and a lot. Each set of, every time a drug is made in, let's say, a batch of 100, that gets a special lot number. So you're not going to find this on every single bottle. Some of this is in the package insert that comes with the medication, because the bottle just simply isn't big enough to hold all of that. Okay, that pretty much covers the entire chapter. That went by super quick. Warning labels, last but not least. These have kind of started to be printed out with the actual label from the say pharmacy as it is, so we no longer very often apply separate warning labels, but as you can see there's a ton of them, kind of giving you again special directions. So for the eye or for the ear, keep in refrigerator, do not freeze, shake well. So those are always helpful hints for the patients to know how the medication should be taken. And again, we're just finishing up Chapter 31 this week, so don't forget to do the Chapter 31 test on Moodle, as well as the assignment for Week 6 and the forum, 250 words of your own, and then 2 responses to your classmates, 100 words each. Have any questions, feel free to email me, and I hope you guys have a great week.